All right, good morning. Hope you had a nice little 3-day weekend, and we're back here learning about scatterplots. So here's the notes we're going to talk about on scatterplots. So the first page just kind of gives you the definition, goes through it a little bit. So you could read this. I'll read it to you, but you can read it to yourself and just kind of look at some of these examples. Then we'll do some examples together. So a scatterplot is a graph with points plotted to show a possible relationship between two sets of data. A scatterplot is an effective way to display data and use it to draw conclusions. So this particular example, the first example, gives you a scatter plot from some data. So it says the table shows the number of species added to the list of endangered and threatened species in the United States during the given years. Graph a scatter plot using the given data. So in 1996, you could see that 91 species were added to the endangered or threatened, 97, 79 were added, and then so on and so forth down the line. And so this data is graphed in a XY coordinate plane. Usually it's just the first quadrant. So what I mean by that is, like, if you think about the XY coordinate plane as a 4-quadrant thing, a scatter plot's going to typically only take the first quadrant, and you're going to graph in there. So you don't really graph the other 2 quadrants, but it is an XY coordinate plane. So in this particular problem, the x-axis would be your year, and the y-axis would be species. So we graph it like this to see if there's a relationship. Sometimes the relationship is a negative trend, sometimes it's a positive trend, sometimes it's all over the place, in which would indicate that there's no trend. So that's what this one's saying. So this one kind of seems to be a little bit of a negative trend, but that's basically how you take data and put it into a scatter plot. So the idea is you want to be able to look at the data in order to draw conclusions. So we're going to do this. You can do this for all sorts of data, and we're going to look at some examples here. All right, so here's an example of a scatter plot that you're going to try to create for yourself. So you got some data here in a table. So you got the game, each game 1, 2, 3, 4, and then the scores. So we're going to try to figure out, and the hardest part about a scatter plot is making up the x and y axis. So the x-axis is typically the top line, and the y-axis is typically that line. So the games, and then the score. So for the games, there are 4 games. So I don't want to necessarily go 1, 2, 3, 4. It's going to give me points just right there. I'd rather spread it out a little bit. So give yourself a little bit of space. I'm going to go 1, 2, 3, 4. So I kind of used every 4 tick marks and made it one of the games. So there's only 4 games, so I could spread it out like that. So on the y-axis, you got a different set. You go from 6 up to 46. So that's gonna create a little bit of a problem. So just counting up, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 tick marks. So if I want to get 46 on there, I'm probably going to make every tick mark, I don't know, we can make it a nice round number. Let's make every tick mark 5. So what that's going to do is going to be like, this would be 5, this would be 10, 15, 20, 25, 30, 35, 40, 45, 50. And then that gives a little bit of a short graph, but if I did every 2, I would have probably only got it, this would have been 40 then, and it wouldn't have been high enough. So basically, I'm going to graph what's in the table. So I got game 1, I scored 6. Let's use a different color for that. So game 1, you scored 6, so it's roughly there. Game 2, you scored 21 points. So there's 20. I'm going to go a little bit higher. 3, 46 points. That was the best game. So right about there. And then 4, I got 34 points. So you got this graph. You don't want to connect the dots. It's not about that. It's about looking at the dots and seeing if there's a relationship. So we're going to talk about a model that might fit the data. But if I was going to create a line that fit this data, it might look something like this, right? So obviously you can't connect all those dots with a single line. So you kind of fill the space between them with a line that sort of fits them. And what we do with this sometimes is we predict off of it. So that's the next thing. But for right now, I just want to make sure we see that there's a how to make the scatter plot. All right, so the next thing, let's talk about correlation. So if there is a pattern to the scatter plot, meaning you could see that the data trends upward or the data trends downward, we call that a correlation, right? So there's strong correlations and there's weak correlations. So we'll talk about that in this next part. So looking down here, you've probably seen this in Algebra 1. It's just a good review, but you could read these 3 things. Obviously, a positive correlation corresponds to the numbers going up, As the x-axis moves forward, the y-axis goes up as well. The negative correlation is kind of the opposite, right? As the x-axis goes on, the y-axis goes down. And then this is just an example where there's no correlation. So there's plenty of examples. If we were teaching this during the year or something, we'd probably have everybody try to come up with an example of two things that are correlated, right? So, shoe size and height, right? There's one right there. Your height and your ability to be a basketball player, these are all things like the height of basketball players in the NBA, right? There's a correlation between positions, right? The weight of players in given positions, the height of players in given positions. There's thousands and thousands of things we could talk about for correlations, but that's just something to consider. So looking back to example 1, the endangered species model. If you think about what it looked like, you go back a little bit if you want to, but that had a negative correlation. As the years went on, the number of endangered species being reported was decreasing. Back to the example we just did, it looks as if as the games go on, the points scored by a high school football team go up, right? So there seems to be this positive correlation, right? And this is where, like, if you want to say, like, what's going to happen in game 10, and you try to extrapolate based on that line, you'd be like, are they going to score like 120 points? Probably not. So the data is probably going to be pretty flat. And, as the games go on, obviously there seems to be trending upward, but it doesn't necessarily mean it's always going to be the case. So, all right, so looking at this next one, we're going to talk about how to match scatter plots to given situations. So zooming in on this problem, it says choose the scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant. All right, so looking at these 3 graphs, right? So kind of, we'll zoom in because you could read below it and get the answer. But if I look at these 3 graphs and see which one could be a scatter plot representing the height of a sunflower seed over time. So let's look at the first one. So in the first graph, you planted it right here, and then it says on that first day it's already 70 feet or inches high, right? And that doesn't really make a whole lot of sense, right? So you're talking about this is the height in inches. The fact that you planted it, it's already 70 inches high, and then it goes down to about 65 inches. You're like, that doesn't make any sense. Why would a plant be shrinking as time went on? And by the time it's at 70 days, it's smaller than it was the day it became. So you look at that one, you're like, that can't possibly be the one. Probably not graph A. Graph B, problem with that one, it kind of does have that upward trend like we could probably think a plant would have, but there's negative days. It doesn't make any sense. When you talk about days, you can't have a negative day. You couldn't go back in time, right? So that one makes no sense because of the negative days. If it didn't have the negative days, this one probably could be, an indicator. The other problem, though, is that it starts at 0 and it's already has some height. And you talk about planting a sunflower seed, it wouldn't have any height if you started at 0. So once again, that's a problem. I don't think that's going to be the answer. Graph C, finally, that looks exactly like what I think we would have. 0 days, you're at 0 height. Even after 10 days, it's like 0 height, and then it starts to sprout and grow. So C is probably a better representation of a sunflower seed growing over time, right? All right, so let's look at the next thing. All right, so looking at these problems, I kind of drew to the right, I drew 3 different XY graphs to kind of see if there's a correlation, if we can come up with one. So the number of empty seats in a classroom and the number of students seated in the class. So as the empty seats increase, the students seated would have to decrease, right? So if there are more empty seats, there are less students seated, right? So in that case, this would probably correspond to the negative correlation, right? So the more, as you move right to left, as the empty seats increase, the students that are present in a seat decrease. So this would correspond to a negative correlation. And why? Obviously, it's kind of what we just said. As empty seats increase, the number of students in seats decreases. Okay, so I'd like you to pause it and try the next 2, and then we'll come back and talk about the answers. All right, so hopefully you got these right. Looking at the answers, example 5B, pets, the number of pets somebody has in the books they read really is no relationship, right? You could have 1,000 pets and read no books. You could have 1,000 pets and read 20 books. Doesn't matter, right? There's no correlation there. There's no relationship in there. C though, as rainfall increases, the reservoir will for sure get deeper. So the more rainfall, the deeper the reservoir. That's a positive correlation. All right. So the next thing we're going to talk about is outliers in data. So when we look at a set of data, sometimes we see a pretty strong positive or negative correlation, but there's like a sample, a piece of the data that doesn't match that correlation. So let me show you an example. So I just made up this random example. So I just took like your score on the SAT and compared it to the number of colleges you were accepted to. So you could see that basically as the score goes up, the number of colleges you're accepted to go up. So what I mean by outlier is like, what if your score on the SAT wasn't that great, but you have a lot of other things going for you, right? So you're like involved in a lot of extracurriculars, you have very good GPA, you have a lot of other things, and then you apply to a lot of colleges that do not really care about the SAT. So that could be like an outlier. So that could be like, I got a lower score on the SAT, but I got accepted to many colleges. So typically speaking, right, the score on the SAT means you'll be accepted to more colleges. However, there could be outliers, like certain students could get a lower score but also get into many schools. So that's the idea of an outlier, right? So most of the data follows this kind of increasing line, this positive correlation, but there are some pieces of the data that might be out of that set. All right, so we're going to go a little deeper into outliers here and see if we can kind of just see what's going on here. So looking at example 6, it says the data in the graph represents the percentage of homework missed during a unit and the percentage of students scored on the test. So what this says is like, this is the percentage of homework missed and this is the percent on the test. So let's just kind of break that down. So this is the percent of missed homework. And if we look up here, this is the percent that you got on the test, right? So as the percentage of missed homework increases, the percent on the test decreases. It's a negative correlation. However, there's this one piece down here. Well, that's a percentage missed on the homework of 10. So about 10% of the homework missed. It's not very much, right? So they did 90% of the homework, but the score on the test was rather low, right? So in this particular problem, we do have a situation where you have one piece of data that doesn't really match the rest. So this is like a negative correlation, except for this guy, which did a lot of homework, but he still scored low on the test. So that's an outlier in the data set. It doesn't go along with the other data points. This last one, you got a whole bunch of students. You got the length of their thumbs. It says the data represents the length of several student thumbs. So this isn't really an XY situation. It doesn't really it's not comparing two things. It's just giving you the lengths of student thumbs. But you can see that one student's thumb is really, really, really long, 31 centimeters. That's not really even possible. So, but that's definitely what an outlier. That's the idea of an outlier. All right, so now that was just a quick crash course in Scatterplots. You're going to practice some of this stuff on IXL. And when we move forward, we're going to be talking about lines of best fit. So I kind of mentioned that in this video, but as you look at data sets, you can predict things in the future if you know how to find the line of best fits. We're going to get into that. So hopefully this helps, and good luck with your IXLs.